Well, we're kind of moving to a web performance session, and I think that performance is something that we all care about, and that's always a bit difficult to catch up because there is so much happening. But I also wanted to know if there is anybody from Finland. It's like a very specific question, like, why is that? Well, how do you call a developer from Finland? Well, we don't have any, so we wouldn't know, right? They're called a nerdic. Oh wow, this is the worst. Okay, Scott.
Next one.
Keep going. Okay, next one. Okay, going with the forest and the Freiburg and everything. How do trees get on the internet? Okay, this doesn't go well. Yeah, they log in. I will just continue. All right, we have Scott with us. Scott, everyone. And there are a few stories I can tell about Scott. Scott is very good at throwing things. That's number one.
We'll see.
Anybody wants? Yes? Here we go. All right, this keeps
chandelier in the way.
But chandelier is important.
It's gonna go
very
straight.
important. Ooh, wow, that's pretty good.
Two for two.
Yeah, sure. You feel free to just throw all of them. It's not like I have. Well, not like that. Just
say.
Well, maybe just 3.
Are you throwing any?
Well, I will. I have to introduce you. Right. So, right. So. I really like your technique, by the way. I have to adapt it. This was a little bit well, maybe no more chocolate for you. Right. So Scott has been around for quite some time, also working around all kind of spaces, of course, mostly web performance now as well. And there is a funny story that somebody mentioned to me many, many years ago because you came up in a conversation. And the conversation went like this. Well, Scott is probably the best front-end engineer, developer, whatever you want to call it, who can ship code while being on a boat somewhere in the middle of nowhere in Laos and contribute to jQuery project working on something that nobody could solve for weeks. He could do just in a couple of hours.
Yeah.
Is that about right?
It sounds familiar. Yeah, I was lucky to have a backpacking period in Southeast Asia and also have a lot of open source work at the time instead of client deadlines. So you, I guess, can hold me responsible for all the versions of jQuery, at least partly responsible, that are still on websites all over the web.
So who is using jQuery in your project? It's okay, it's a safe place.
Listen, the syntax, I still miss it.
Yeah, yeah.
Very conversational.
Yeah. Well, one way or the other, let's see what we can do, how we deliver for performance. And so please give a warm round of applause to Scott JEHL.
Thank you. Good morning. All right, welcome to Delivering for Performance. It's so great to be here in this beautiful old city in the Black Forest. It's my first time here, and I've really loved it. I was able to get out for a walk in your nearby woods earlier this week, and it's so quiet back there. It's so pretty and lush this time of year. And while out on that walk, before long, I was alone on this long gravel trail, which climbs up the hill behind the venue. And I came across this contraption that some of you probably know about, which, first of all, massive, right? And I think almost certainly a slide and not a wood chipper for the forest department, probably. We don't really have things like this in the woods in the US. Instead, we have lawyers. So I peered into the abyss at the top, and I thought for a minute about sending it all alone. If a web designer falls in the forest and nobody's around, did they ever ship anything? I don't know how it goes. But then I started to think about the Brothers Grimm tales that I read as a kid that are from around here, I think. And I thought, how do I really know if Rumpelstiltskin's not hiding in the dark in there? I couldn't see it. It seemed possible to me. So looking before I leap has served me well so far, so I didn't do it. But maybe I need to go back if someone wants to join me I'll watch you go first. Anyway, as I was putting together this talk, it occurred to me that I was setting out, yet again, to sing praises for building earnestly with progressive enhancement and an ethic of fault tolerance, which is something I've been talking about for a really long time. 2025 now. That's 25 years since I first typed an HTML tag into a text editor. Feels crazy thinking that. And for almost all of that time since then, I've been writing and talking and wondering about this same sort of thing. How can we build websites that are simple, faster, and tolerant of failure when things don't go perfectly well? And admittedly, this is starting to make me feel a bit like a monk illuminating a medieval manuscript with a candle while AI is over here generating 75 new JavaScript frameworks next door. But the truth is, techniques evolve, right? But the same guiding principles that I've been using all along have continued to pay off, and even through today. Look before you leap, have a plan, test widely. For 15 or so of those years, my work happened in the agency world. So I worked at a place called Filament Group. I got to work on some amazing projects there. As a consultant, there's often this sort of outsider's perspective to how your work lives on after you throw it over the wall. And I always found I wished for more insight into how well our code was really working after we delivered it. Didn't always get it. Sometimes it was nice. The vantage and scale of the work that I do now is a bit different than that. So today, I work on the core web platform team at Squarespace, which is a fancy name for the performance and accessibility team. And we're tasked with maintaining and constantly improving performance and accessibility across all our products, which means helping support literally millions of websites that run on Squarespace, each one a business large or small, each critical to its team and its audience. The experience of working at this scale has given me a different perspective, I think, into patterns that work well and those that don't, particularly for users in regions of the world where they have differing circumstances. So I thought it would be nice to share a bit about the process of working on this sort of team and some of the tricks I've found helpful in building more resiliently. Grab my water. So before that, I kind of wanted to talk about the state of performance in general right now. Maybe some of you are even surprised to hear that there's much to say about performance in 2025. You might think, performance, this is the future, right? Like, haven't we solved that problem by now? And I think you'd mostly be right to think that. Like, we're living in a future already where good performance is easier to achieve than it ever has been before. But as the saying goes, the future is here, it's just not evenly distributed, right? So the way people experience the web today is highly dependent on their circumstances. And that's because our medium is delivered to a diverse spectrum of devices and network conditions. Consider how popular mobile devices performance has changed over the last decade or so. This is from Alex Russell's post last year, The Performance Inequality Gap, and it shows performance benchmarks for various popular devices since 2013. 10 years ago, or even more, popular devices kind of had relatively similar performance. There wasn't a big gap between them, which is to say they were all kind of slow by today's standards. Nowadays, a new iPhone can be 5 or more times faster than a budget Android device that people are using. And by faster, I mean how efficiently and quickly it can not only download code, but then churn through the code that we send it. Now, if you only intend to deliver performantly to folks here in Germany or in the US where I live, your job's going to be easier, right? Your users are likelier to be on a mid to high-end device, an iPhone, a Samsung. This is the Amazon bestsellers page here in Germany for mobile devices. Generally, they're all pretty capable devices. Of course, companies today care to reach a wider audience around the world, right? So if you look at that same list in another region, say India, you get a very different list. And that's not to say they're all low-end devices, but the spectrum of capabilities is wider. Many of these devices cost $50 to $100 versus the 1,000-something plus iPhone that came out yesterday. It's pretty wild. and they're often quite underpowered compared to what web developers are used to using themselves. And that kind of sets us up in an interesting place, right? Because with exceptions, we web developers tend to have access to very nice devices and fast connections. And experiencing our own work on those devices in very ideal, relatively ideal conditions every day can kind of give us a skewed perspective. I made this timeline to just rudely reduce the entire history of web performance into 2 phases. Websites have been slow, or too slow the whole time, but for different reasons. Basically, in the old days, it wasn't our fault, right? It was hard to deliver websites quickly because things were slow. We had constraints that were beyond our control. But sometime around 2013, things started to change, and it's safe to say the influencing crowd in web development started to experience a web with reduced networking constraints and device constraints. And really quickly, the way many of us popularly delivered websites changed. And that change in practices ensured that we would continue to deliver poor experiences to some users even as things improved. So to put it another way, around that time, we started shipping just an absolute boat ton of JavaScript, right? And perhaps to us, it downloaded pretty fast, right? But byte for byte, JavaScript is really costly to parse after downloading, especially on slower devices. And worse than that, more and more websites were starting to use that JavaScript to generate the HTML after it was delivered to the device, right? So fundamental change that was happening in the way websites were popularly delivered. And that's a shame because there actually is an unopinionated right way to deliver websites initially to a browser, right? Handing the browser a box of parts and instructions to put the HTML together after it arrives, it's not actually that way. By the way, I drew this label, and that is web page in Swedish. It looks like website. It works either way. As anyone who has put together an IKEA cabinet knows, though, it can be a trying experience, right? You're asking the customer to do stuff that not everyone's very good at, let alone quick at doing it. Browsers are designed to receive HTML as text, static text, quickly identify resources inside that text, start fetching it while it's rendering for display. It's very efficient. They're built to receive the cabinet sort of put together already, right? Instead of assembling it after arrival. On the other hand, the best way to ensure that our users are going to get very different and unreliable experiences is to make them do more work. My colleague at Squarespace, Tom McCabe, jokingly calls this pattern outsourcing our compute, which I think is pretty good for LinkedIn or something like that. So I bring this up because JavaScript overdependence is one of the more common performance challenges across the web still today. It's a lingering problem. There's better ways to do it now, but it's taking a while to get everyone moving their practices forward. So just as tech started to improve enough to alleviate long-standing performance problems, we kind of made our own. And in doing so, we shifted our performance burdens from the network to the device. So how do we know about this if we don't happen to have a budget device lying around? Well, first of all, I think you should have one of those lying around. Anyone know what this is called? I call this a dev tool, okay? You need one of these. This is one of the physical devices that I have in my test lab at work. And I think you should get one, and you should do some vibe testing on it. That's a term I want to make happen for the youth. Start vibe testing your sites on real devices. This one's a Motorola G Power from a few years back. If you've ever run Lighthouse, this is the phone that it emulates. My test devices are all pretty recent, popular, cheap around the world. Most don't have a 5G chip. I'd suggest buying some, and then test them in realistic conditions, not just on Wi-Fi. Test them on constrained speeds that happen elsewhere, right? And you don't have to walk into the death slide forest to find those speeds. There are apps that can do it for us. So this is one called Charles Proxy. It's been around forever. It can share a connection to external devices, and you can shape the connection speed on that. So you can pretend that device is receiving a 3G connection or something like that. It's good just for level setting. Just get an idea of how your stuff is working for people. And you can fake connection speeds like this one that I experienced on the way here from Frankfurt on the train Wi-Fi. Or slower than that, right? that was actually not that bad. So once you're done vibe testing, you can use tools to look at agreed upon performance benchmarks. And the community has created some metrics that are really great proxies for users' perception of how a page feels to use. Google has identified 3 of those metrics as core web vitals, they call them, right? So these are those. LCP is the largest contentful paint. It's the moment the biggest portion of content, biggest element, visually appears on the screen. Google says 2.5 seconds or so is good for LCP. IMP is a newer one. It measures sluggishness in user interactions, how long it takes for JavaScript typically to fire after you click something. And then CLS stands for cumulative layout shift. It measures how long or how much the page jostles while it's loading. 0 is the score you want, no jostling. So those are the core web vitals. There are great tools to help us measure this stuff in a variety of ways. These are some of them. We don't use all these at Squarespace, but I wanted to mention them just personally because I think they're all great. And there are more than this, of course, but Speed Curve, Caliber, Web Page Test, Debug Bear, Lighthouse, various Google tools. We have a wealth of great tools for this stuff now. So they do synthetic testing, they do lab testing, they do field testing. What's synthetic testing mean? That's when we deliberately go out and test a site using like lab conditions. Emulate a browser, point a test at it. This is Caliber app that I'm showing right now. They have a free page speed test that you can run in mobile or desktop conditions. It's really nice. They have more products beyond that from there. But this is a good way to get a quick idea and get some tips on your performance. Web Page Test is another one, great synthetic tool. Gives you a bit of a deeper dive. I used to work at Catchpoint before I joined Squarespace, and I got to build a feature into this tool called Experiments. It's really fun. It lets you try out optimizations that sort of inject themselves mid-flight before the HTML lands on the device. So you can sort of test things before actually building them into a site and see if they're going to move the needle before you do the work. And then there's synthetic monitoring, which a lot of these tools also offer. This is a screenshot of Debug Bear's synthetic test results, for example, which can run scheduled tests, lab tests, to keep track of your scores in Lighthouse, make sure you don't have regressions. Matt from Debug Bear is doing a lunch session, I think today, on performance, and you should definitely go to that. And if Matt says anything that contradicts me, definitely believe Matt. Matt knows what he's doing. So lots of tools support these kind of features. So contrary to synthetic testing, we also have field testing, which is popularly known as RUM, or real user monitoring, which is basically, every large-scale website does some sort of RUM these days. It allows us to get anonymous performance data from people that are actually using the things we build. So it's the truth, right? There are some public RUM sources that you can use to get information about your websites. One of those is called CRUX, which stands for Chrome User Experience Report, which I don't want to dwell on this, but that's not how acronyms are supposed to work. Using CRUX, you can find out real performance conditions that people are experiencing on your website, in Chrome at least. It's collected by Chrome anonymously and sent to Google. So it's limited in that way. It's not all of your users. It's not iOS, but it gives you a good idea of mobile and desktop use. There are public tools you can use to look up performance information from CRUX, see how your site's doing or your technology. For example, this is a chart of Squarespace's LCP across the last 5 or so years, improving along the way as our performance team joined and made a lot of LCP targeted improvements. So these tools are great. You can look them up and use them yourself. RUM is also tracked and collected by companies explicitly, right? So typically there's like a script tag in the page, and it posts anonymous performance metrics back to the company to keep track of things. A lot of these providers have that. This screenshot is from Speed Curve. Their RUM is pretty nice. One thing they offer is You can correlate other business metrics with your performance to try to talk about how it's improving business metrics. So that's nice. At Squarespace, RUM is pretty interesting, I think, because those anonymized metrics come from all Squarespace websites rather than just one, like a business typically has. So that means we have this view across all users around the world. They're using all the websites running on Squarespace. So I think it's one thing to get up on stage and say, websites work differently for different people, right? But it's another thing to see evidence of that every day. We've done a lot of work to make sure our LCP, on average, is really good for all our users on average, right? But broken down by country, especially in places with more constrained devices and connection speeds, we can see that it changes, and there's opportunities to support better and better in the higher percentiles, right? So if you look at these blue lines, you can see, LCP looking good in Germany and then sort of creeping up. And to me, I think I like to focus on those 90th percentile because it represents an opportunity to broaden customers' reach. There's this great article about this from a decade or so ago, and it gets referenced all the time in performance, but I'm going to say it again because it's just so good, right? The story goes that YouTube ran an experiment to serve a dramatically lighter version of YouTube to see how fast they could make it load, and as the RUM data started rolling in, they noticed something they didn't expect. Performance was getting worse. On average, their site was taking longer to load. So what was causing that, right? Well, it turned out that the new lighter version was actually light enough, it became possible to use at all for a lot of regions of the world that just couldn't load YouTube to begin with before. So they weren't even on the radar. Suddenly the average is worse, but they have a broader audience, right? So performance has this enabling effect. I think that's pretty inspiring. So next, I wanted to walk through some steps to look at a site's delivery performance and try to improve it. For Squarespace websites, we have pretty good web vitals, as I mentioned. Historically, LCP has been the metric we've targeted for, like, it needs the most improvement, so we've focused on that a lot. And we now have 75% of our users with good LCP. But we still want to get that higher, right? We want like 90%, even higher. So how do you go about that kind of work? Well, in my day job, it's a combination of watching metrics to see if something needs improvement. That's the starting place. Then running audits on certain kinds of sites to try to find the bottleneck. It's like between a detective and a janitor, somewhere in the middle there, right? Cleaning up after other people's, not necessarily mistakes, but patterns that add up over time to bottlenecks. Ultimately, we test and prove out ideas and then roll out fixes very gradually, right? So for sake of example, let's just walk through an example minimal website that I put together with some bottlenecks seeded in there to talk about what's going on. So to start, I'll give that site a quick run-through web page test just to see how it's performing. This is a mobile test result, slow phone, 4G connection, not too bad. We can start to look at the results. We have time to first byte over here. It's not too bad, 900 milliseconds. That's when the HTML starts to arrive, so that's good. LCP, though, 5 seconds. That could be better, right? We want to improve that. Let's see what's contributing to it. So first of all, this is the LCP. Images by far most common kind of LCP element, anything at all. LCP request 16 in this waterfall. That's our WebP. It's way down here, right? And these are the connection steps to the server. User scrolls down the page. Images with this attribute will show as they enter the viewport. But you don't want that on your LCP element because the browser is going to wait for layout to decide whether to fetch it or not. For LCP, we want that request to go way sooner. So definitely pull that attribute off of your important images. Let's do that. Let's remove it. I did that in my test site and see what happens. And the red border represents LCP. So we just moved it back about a second just by doing that. That's great. Just improved LCP a little bit. And then we can see what's going on in the waterfall. The image is no longer down here. It moved all the way up to request number 3. That's great. The browser discovered it early and fetched it. So that's good. Another thing we can do to that image to make sure it has a high priority when it's fetched is to increase its priority so it doesn't contend with other or compete with other requests and get downgraded. So in this page, it's kind of a simple site, but with sites with more requests, you might see that problem. So one thing we can do is use fetch priority high to apply that behavior and make sure that it has, we're hinting at the browser that you should request this image with a high priority. So that looks like this. You can set it to high, do this on your LCP images, test it out. It can be really helpful in getting them to load as fast as possible. So those are two great things that we can do for LCP images. To figure out what's holding back LCP now, we have to go back to the waterfall and figure out, our image is loading pretty quickly. What else is the bottleneck, right? So we see, some JavaScript requests in there, but they're not blocking this dotted green line. That's where the page LCP happens. So they're not necessarily the bottleneck. But we do have those render blockers, the CSS files, right? And as you can see, they're taking a little while to download, actually longer than the WebP third request. So those are a bottleneck. This is where I want to talk about a little feature called LCP subparts, because it's handy in debugging. I borrowed this graphic from a Debug Bear article. It's a good one. LCP subparts are the steps that contribute to the LCP elements rendering path. So we have time to first byte, we have resource load delay, we have resource load time, and we have render delay. You can look up what all of those represent on the Debug Bear article. But the last one, render delay, is one I want to talk about here, because that represents when the LCP element is downloaded and ready to render, but something's happening and it's not rendering yet. If you run a test in Lighthouse, you can look in, like in Page Speed Insights, for example, you can find out about LCP subparts. All other tools tell you about it too. And if you look at that in Lighthouse, you can see render delay is listed as, in Lighthouse anyway, 2,000 milliseconds. So the image is downloaded, but something else is blocking it from showing before LCP happens. So if we go back to our waterfall, we can see and confirm again that that period after the WebP, in this case, is downloaded, it happens early. We could make that image lighter. We could request it sooner. It's not going to improve LCP until we get the other bottlenecks out of the way. So in some cases, there are options here. If the server takes a little while to respond with HTML, that slows the discovery of style sheets in that HTML. And the browser can't find those style sheets. We can tell the browser about it a little earlier, so you can give it a hint that files are going to be needed. So I want to quickly explain this little feature that I won't be able to fully explain given the time, but you should look it up if it's potentially interesting to your dev team. So there's this feature called 103 early hints, an HTTP response code, and basically it lets a server, while it's still working on an HTML response, it can send a little information to the browser in the meantime and say, why don't you go fetch these things that you're going to need in a minute, and we'll give you the HTML a little bit later. So if we pretend that we're sending those sort of hints from the server for our CSS files, those render blocking requests, we can see an effect, sort of like this, right, where it moves those back. The HTML request is still working, but a little hint got sent to the browser, and those load sooner. So that could help your LCP. Browser support for those are good. There's some tricks, gotchas. This is a good article. I'll share the slides. You should read up on it. There's a lot more to it than I showed. So maybe a 103 can help. What about getting render blockers out of the way instead? Let's consider something more aggressive. So first of the render blockers was one of these third-party fonts, right? It's problematic for a few reasons. It's on another domain. It only has font rules, font-based rules. Ideally, you want to define those on your own site and not make a whole request just to get those rules, right? In the case of something like Google Fonts, they're open source fonts. If you're able, just self-host them, download them, reference them on your own server. This will get that whole render blocking request out of the way. And if your LCP element was text and not an image, this would really help get that text rendering just a little bit sooner. So that could help, but often the tricky thing about render blocking requests is you don't really see the big benefits until you speed all of them up, right? It's like a race where like we're waiting on all of them, and you're only as good as the slowest one. CSS render blocking is actually good. We want it to block rendering. We just want our files to be as small and as fast as possible, and that's really tricky. In the case of like this example site that I'm showing, it sort of represents, sorry, represents a common scenario that you see on websites that have been around for a long time. You know, there's legacy code. The CSS grows and grows and grows and grows over time, right? So you picture a site with like a lot of layouts and global style sheets that sort of offer all the layout variations that could appear on the site, but a given page on that site may only use a subset of those styles, right? This is such a common problem. And those ultimately start to get in the way. So what can you do about it? Well, first of all, you could like rebuild your app, right? So it only delivers the CSS you need. I highly encourage doing that. Convince your management that we're just going to pause on feature development for a while and sort out our CSS styles. It's possible, it's happened, but sometimes it's really hard to fit into the workflow. So alternatively, you could consider post-processing the CSS to try to automate that process. I'm a big fan of, at conferences, sort of like sharing ideas that aren't like fully baked, or like, I'm looking at this, I find it interesting. This is one that's sort of been evolving over the years, this idea of critical CSS. The idea is to use a build tool to identify the styles that are relevant to an entire HTML document, send those at a high priority, and then send the rest asynchronously, right? If you've heard of this before, people used to do it in a way that would like try to isolate the styles that are above the fold and then like load the rest later. I'm not really a fan of that approach. There isn't really a fold. But there is a whole document, and there are styles that we can pretty reliably identify and match as relevant to the page. So a tool like Purge CSS can do this for us and separate out our styles so we could inline them there and then load the full style sheet at a low priority. And we can do that not in the best way, but with a workaround by using this unfortunately common media print hack that gets the style sheet out of the rendering path. So the reason I bring this up is not to recommend this pattern necessarily. You could also put the style sheets at the end of the document, get them to load without blocking rendering, and skip this whole pattern. But just to say that if you get render blockers out of the way or speed them up, the result can be pretty dramatic. And there's no mistake in the fact that there are so many websites that are popular that inline their important CSS because it's just really fast. It's been going on for decades. So you can see how it moved LCP into the, I think it's 2.1 seconds now on a 4G connection. That's great. Google says that's a good time, right? Here's a fun look before you leap example that I wanted to show. So if you've ever worked on a big team with conflicting priorities, you're going to run into these situations where one team wants to do something. It's really hard to do without sacrificing something that you care about, right? So let's say design ships a really slick animations feature, but it slows down performance on slower phones. This is a real scenario. It's actually one that we faced at Squarespace. So in these kind of cases, my team looks to support the feature in an ideal setting while playing defense to make sure it doesn't degrade the experience or make it inaccessible for some people. So Squarespace has this feature where elements animate in as you scroll through the page. People can configure it. It's been around a long time, and it works very broadly in the browsers we support, which is pretty far back. Now, you're all pros here, so I need to caveat this. There's a new CSS feature that does this too. It's called animation timeline, or scroll timeline as well. And it lets you do this with CSS. It works in Chromium browsers so far. That's great. I'd recommend checking it out. I think I'm showing animation timeline here. There's scroll timeline as well. For us, it wasn't broadly supported when we were rolling out our animations feature, so we had to think about it a little differently, which means often you're going to end up with some JavaScript kicking in the animation, right? Like maybe intersection observer waiting for an element to enter the screen and then adding a class to it, something like that. Super common pattern around the web. I'm simplifying it here, but an H1 starts with opacity 0, JavaScript adds a class to it, feeds it in later. But what happens if JavaScript takes a long time to load or run, or maybe it has an error? Potentially, you could leave that H1 completely hidden. So I have been enjoying this pattern for sort of making self-destructing initial styles that only live for a short period before we just give up and show the element. So in this case, I've got the fade-in animation that I showed earlier, but then I added some keyframes for an animation called hide safely that just does the same effect the whole time, opacity 0. And then instead of giving the H1 opacity 0, I give it that animation and give it a maximum of 3 seconds to have that opacity style. If the browser takes forever or never runs that CSS over there, the element will still show. It'll still be an accessible page. It's showing it running. And then if I delete it, 1, 2, 3. This saved our users on really low-end devices and connection speeds a massive amount of time on LCP if things showed at all, if the JavaScript happened to load at all. So, good tip. Another feature I just want to send you away with to think about is a new one. Say we're navigating not for the first time to a website, but between 2 pages on a website, and the request is coming from our own servers, right? Well, those are generally easier to optimize than requests that are just fresh, right? We have cache that we can work with. Generally, things are going to, on their own even, if they're configured right, start to load a little quicker than a first-time visit. But there are some good tools that we can use to make that even better. We have these link elements, rel prefetch and pre-render. I'm going to show this briefly before caveat. So what these do, prefetch is a low priority fetch for things that a next route might need, right? Maybe those are resources, or maybe it's the HTML document itself. So kind of like if you have a good idea that you're going to need these assets in a future navigation, you can get them out of the way sooner, and then the next page that uses them has them in cache already. Pre-render is pretty neat. It actually loads the entire route in the background so that if you were to visit it, it's there immediately, right? So if you have a section of your site that's client-side, single-page application kind of thing, this is potentially a really good pattern. Quick caveat, don't do it this way, though. This worked for a little while, and then it's now deprecated. There's a better way to do it. It's called speculation rules, and this is a lot of code to just put up on the screen. I'm sorry about that. You don't need to understand what this is doing. Just come, or just leave with the takeaway that this is a cool thing to check out. It has smart heuristics to prefetch and even pre-render some pages based on user conditions like hovering near a link. We could request it a little sooner ahead of time than it would happen if you clicked it. And that's, a complex API. So go check out this link. I'll put the slides up. I'd recommend looking at it. There's a lot of caveats to using it, but it's very cool. And this site actually has it in play, so check that out. You can look in DevTools and watch it happen. So to wrap up, as web developers, our first step is thoughtful delivery, right? Delivering efficiently and resiliently, regardless of our users' circumstances, is embracing the strengths of our medium, I think. So have a plan, look before you leap, use the great tools and metrics that we have, and maybe vibe test a little bit on a phone. That's all I have this morning. I have an online course that, if you're interested, it's about web components. It pairs very, very closely with the sort of ideas I was sharing in this talk. If you use that code, you can get 50% off this month. And if you happen to be from the US, our team is hiring. So go to Squarespace Careers. Thanks so much for your time.
Thank you so much, Scott.
Yeah.
Oh, we have so many questions, so many questions. Thank you so much for this. I think actually speculation rules are amazing. It took me a while to figure out how it all works because it's.
I'm still struggling to remember all
it's
the.
like, and I don't know why, but for some reason when you set them up, it's like sometimes it works when you look at the application panel in Chrome. So sometimes it doesn't. So I still really had to play with it for quite some time.
Yeah.
There is no like a builder to create your rules. You kind of have to really know what you're doing.
Right.
I think it has a lot of potential.
Yeah, I do too. It's not something we've deployed, but some companies have. There are great case studies that you can check out how like their adventures in implementing it and all the gotchas that happen along the way. It's complicated, but it's potentially, especially for those single page app kind of parts of a site that are just really hard to get a good LCP time without rebuilding your whole site with Next.js or something like that.
But I also think like that we're getting kind of to the point where we can do so much with web performance. We're going to get all this little control about all the little things, the fetch priority, we can do speculation rules, we could do service workers. And there are some questions around that of different people saying, well, are service workers still a thing? Because I never see them anywhere, right? And at the same time, actually, it also came up. Speculation rules a thing. I don't see them everywhere. Is it like we are just so much of stuff that we have that actually it might be difficult to actually understand how to orchestrate all of that together?
I mean, I can relate to that. It seems like we have a wealth of tools now, and some of them do similar things, and there's a little overlap. Service workers are definitely, still a thing. They happen to support later navigations, the worker downloads in a way that doesn't really support the first visit so much as caching and storing files offline and, setting yourself up for even offline browsing. Totally relevant still, and very different than speculation rules, which, but there is some overlap.
Sure.
Yeah, it's kind of daunting how quickly web performance is moving, and it's hard to keep up. But.
Yeah. Also, I think that there is a lot of, I guess, uncertainty or like a lack of clarity around what would be a good stack to use in general. Because when we think about, like, let's say we need to set up a new relatively complex project, and so what do we do then? Do we go React as a default? Do we go Vue? Or do we go web components? And you've been quite vocal about web components. Is anybody using web components, by the way? Okay.
Wow, that's so many more hands than like a year ago,
Yeah. So is it like, do you have, let's say, how would I put it best? How do you make this architectural decision where to go?
Yeah, well, I think, I think web components are really interesting. They're, they come with caveats just like any other pattern, and they can be tricky to work with too. I think a lot of teams are using them in a sort of transitional approach where, web components are built on APIs that or sub-features, I guess, and one of those is custom elements, and a custom element is just an HTML element. JavaScript frameworks like React and Angular and all the rest, they all support HTML inside them, right?
Yep.
So that HTML could be a web component, right? And a lot of teams are finding that's useful to start to, slowly move the interiors of, their React app over to web components that can be shared outside of React and, loaded in environments that aren't using that same JSX templating or whatever. Right. I like that approach because it's, it's measured, and frankly, it's a lot of work to convert anything between one framework to another. I guess agentic tools do it pretty quickly for us now, but yeah. I mean, I haven't had a lot of success doing that without, babysitting the steps, and you would expect to want to do that.
Yeah.
So, yeah.
I think it would be just a matter of time until we have a question about third parties and how to deal with third parties. What would be, because we had, or we still have Party Town for a while and
Yeah.
those like that. What's your take on that? And I don't know, I mean, you probably have some third-party scripts as well.
Yeah, they're one of the more challenging aspects of getting a page and all its resources to load quickly because they add little connection steps. You're reaching out to a new server all over again. And I showed, I think, rel pre-connect. That's a way that you can at least tell the browser, like, you're going to need to connect to fonts.mysite.com in a little while, so go ahead and get that out of the way now. And that'll speed it up. It doesn't have to make those steps when it makes the request. But yeah, third parties, I mean, it's often the bottleneck, right? Not only the connection steps, which are often fast, but just that a lot of code lives on third-party domains and JavaScript, widgets and things. So yeah, it's often what ends up slowing a site down.
Yeah, we have quite a few more questions, so I want to go through them. Marked as bold and green, right? So don't worry, I'm going to read it out.
Got it.
So that's very important.
Yeah.
Well, I guess I'll just go through them. First one is, Chris is wondering, is it still a best practice with HTTP2 to merge multiple static assets like CSS into a single one to save on HTTP requests?
Yeah, so the idea of, like, in the past we would try to combine requests. There were limitations on the number of requests that a browser could actively make a long time ago. We don't have those constraints as much anymore. The technologies have improved a lot. So often, we can see better performance and better caching by splitting files apart and letting them load individually. Then another site, section of a site may need a subset of those, and it doesn't need to download the whole file all over again with a little difference in it. I would just say there's no rule on what's better. You have to test and compare what's working in your case. But yeah.
Daisy is wondering, what is your advice for performance testing for web components or web components library? How would you test web components? Or
well, I mean, web components are, at their core, they're just HTML with a little, I mean, you could start with just HTML and use them to enhance it a little bit. That's my favorite way to use web components. Or you can use web components to build them much more like a, single page app React sort of JavaScript-centric pattern. And for a lot of teams, that is the way that makes the most sense. I mean, Photoshop runs on web components now. I don't think they have a big use case for server rendering in an app like that, though I'm sure it would make it a little better for people if they did it. So testing, I would just say use the same tools that you would test performance for anything else. It's just HTML.
Okay. There may be two more. Jonas is wondering, I recently noticed, that's an interesting one, noticed that the screen readers on some of my users are up to 10 times slower than the site load. They just don't start reading for some time, even though the text is already rendered. Is there a way to extract some metrics to understand what's going on there?
That is such a good question. So Marcy Sutton, anyone know Marcy, her work? Yeah, she's really great. Wrote about this a lot in the past. I don't actually know the current state of the bottlenecks, but essentially, if you render a page visibly, but that page is still waiting on churning through lots of JavaScript, often the screen reader is not reading the page aloud until it finishes all of those steps. And it sort of, it makes for a big gap in experience, delivery experience for sighted users and people who are listening to a page audibly. So yeah, it's real. Yeah, I'm not sure what to say other than, it's just like this constant effort to try to reduce the amount of JavaScript that we're shipping, figure out ways
or postpone it for later.
Postpone it, yep.
Yeah, maybe one final, and then we have so many more, so I hope that you will be available later as well. Mario is wondering, all those tricks like fetch priority, etc., from my understanding, can only be picked up by the browser if the HTML is server-side generated. Would you say that client-side rendering with React in general is a bad practice?
Yeah, so that's a great point. Like if you were, in the IKEA box example I was showing, lots of features that you would apply to like an image element to get the browser to increase its priority and fetch it earlier. You're forfeiting all of that if you generate your HTML after delivery, right? The browser is designed to receive text HTML and start looking through it before it even builds a DOM. It's finding references to images and things and style sheets that it can go fetch while it's still working, right? And if you are just delivering an empty div and some JavaScript files and sort of taking like a App Store approach to delivering your website, you forfeit a lot of those built-in optimizations that are, they just won't work the same.
Right. And then the most important question of them all, where should people gather to explore that thing that you showed in the forest together?
Who wants to go down the slide?
Anybody wants to go? There is 2, 3, I think.
All right, I'll watch you. It's, I guess I don't even know how I got there, but you walk sort of back behind, it's not far.
Okay,
and
so you will
like
be up for an adventure to go with a wonderful group of people.
There's a lift that you can ride up the hill. I walked under that.
Yeah, so if you would like to join that adventure, you can find Scott next to Fireplace. You can also just ask questions about performance or anything else as well.
Yeah.
It's all fine. So thank you so much, Scott, for being with us.
Thanks so much.